Bienvenidos, Ushamdi, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the CCNP ENARSI version 8 course curriculum from the Cisco Networking Academy. And in this packet tracer tutorial and activity, we're going to be taking a look at additional OSPFv2 advanced features such as authentication. And we're going to dive into RFC 2328, take a look at the different authentication types to make sure there's a clear understanding as to which is the default and what options are available to us. And so this is Packet Tracer Activity 7.2.2. So let's take a look at Packet Tracer Activity 7.2.2. You can see here we have a basic LAN setup with routers A, B, and C. And then we've got our web server out here, out to which we're going to be testing our connectivity. So this activity, unlike some of the activities you've seen, is actually going to simply give you some requirements, and then you're going to have to implement those requirements based on the knowledge that you've acquired in this course to this point. So let's go ahead and dive in. So using the following requirements, configure OSPFv2 on routing, or OSPFv2 routing on router A and router B. So let's go ahead. We'll start alphabetically. And here we are on router A. We'll go from user exec to privilege exec with the enable command, and then into global config with the configure terminal, or just conf t command. So we're going to say router OSPF, and that's our process ID. Remember, it can be from 1 to 65535. So router OSPF 1. Now, it says configure the network address for each interface under OSPF. In other words, we're not going to be going to the gig 00 interface and saying IP OSPF 1 area 0. We're actually going to be setting that right here, right? So we're going to be using the network command to do that. Now, there's some other things that would have been nice to see as part of this activity. One of them would have been, how about the router ID, right? Let's go ahead and set a router ID value and hard code that in here so that we know what that is. And maybe a passive interface default and a no passive interface gigabit Ethernet 00. And again, these are things for which we're not being given points, but these, again, are best practice actions that you would want to take when configuring a router for OSPF. Now, let's go ahead and say do show IP interface brief. And we can see here it's pretty straightforward. We've got a single address, a single subnet, and we can see that subnet up above right here that it's going to be a /24. So this is going to be a pretty straightforward network statement. We're going to say 192.168.1.0.0.0.255. Again, that is the wild card mask, not the net mask. It's the inverse of the net mask in dotted decimal notation, referred to as the wild card mask, and then area. And it's interesting when I look at this, I think it says in here somewhere everything's going to be in area 0. But that is definitely what we're going to go with, is just simply area 0. And it's funny because they say configure MD5 authentication for area 0, so we're going to be area 0. So let's go ahead and say do show run and pipe that to section router OSPF. So here's our OSPF configuration at a section stanza as it stands right now. We've got our router ID. The log adjacency changes was auto-magically put in there for us. Passive interface default, we're no passiving gig 00. Because this is a broadcast, or will be a broadcast network type for OSPF. And so this is something that we would go ahead and also, as we're taking a look at this, and I'll apply this here in a second. So we could, theoretically, if this was connected back-to-back, like a router A connected directly to router B with an Ethernet cable, do the IP OSPF network type and make it point-to-point. But here, this is a broadcast network type, right? And so how can we tell that? Do show IP OSPF interface, and there is gig 00, and you can see right up here, network type is broadcast. All right, let's take a step back here and make sure that we've got everything so far. So OSPF priority set to 150 on the LAN interface for router A. In other words, we're increasing the IP OSPF priority to give router A the preference or the advantage to be elected as the designated router. Because again, we are on a broadcast network type, so you will have a DR, BDR election. In fact, router A, since I've been talking, is going to wait for 40 seconds, about 40 seconds, right? And that's what that wait value is here in the output of the show IP OSPF interface command. That 40 seconds is how long router A is going to wait before it just basically says, hey, I am the designated router. And you can see right here, designated router, there is the router ID for the designated router. That is my router ID. So I've elected myself as the DR. So let's go ahead and we'll set the priority anyway. And where are we at here? Interface gigabit Ethernet 00. We're going to say IP OSPF priority. And you can see that the value ranges from 0 to 255. Here they're asking for 150. And you'll notice that now we are receiving some points. So we're up to 6 percentage points here. Now, the OSPF priority for the LAN interface of router B is going to be set to 100. We'll talk about that in a second. And again, this is just router A and B that we're dealing with here. So set the hello interval. Since I'm on router A and I'm in int gig 00, let's do that now. IP OSPF hello interval. We'll set that to 5. Now, remember, on real Cisco routers, what's going to happen? It is auto-magically going to change that, change the dead interval to be 4 times the hello interval. However, let's go ahead and say do show IP OSPF interface. And you can see that Packet Tracer does not do that. So they're going to force us to say IP OSPF dead interval, and we're going to set that to 20. Again, this is something you would not do or not have to do on a real Cisco router running real Cisco iOS. And we saw that on the real routers, which I'll be pulling up here in a second as we talk about some authentication and the different types. And so a great segue, now we're here. So configure MD5 authentication for area 0. And our key is going to be area 0 PA55, which is basically they're just saying area 0 pass, like area 0 password. Now, there are 3 types of authentication that we are concerned with when we talk about OSPF. And so here is RFC 2328, and this is a great RFC to make your best friend. And if I was to come down here and say authentication, it should be section D. And here you go. And the exchanges are authenticated. Now, what this does not mean, right? There is a field in the OSPF header that's going to carry the authentication information. It is not, and I repeat, when you set authentication up with OSPFv2 for IPv4, the way we're going to do it using MD5, we're basically exchanging a hash. It is not encrypting the OSPF traffic. And with OSPFv3, this it can be a little confusing because with OSPFv3, we sort of embrace and implement the IPsec suite of encryption protocols, which is different from what we're doing here. So the short of it is, Section D is going to talk about authentication. There are 3 types. There's null authentication, referred to as type 0. And that is the default, because null authentication or type 0 authentication is we're not using any authentication, right? And that's exactly what we're doing right now. There's no authentication configured. So that would be type 0. Type 1 would be a simple password. And again, if I scroll down here, you can see there's a little larger explanation as to what's going on for the null password, null authentication type. And then here's the simple password authentication type. Now, simple password authentication is probably not the way that you want to go because of the statement right here, right? Anyone with physical access to the network can learn the password because it's in plain text. Then we've got cryptographic authentication, type 2. So type 0 is null, type 1 is simple, Type 2 is cryptographic authentication. And this is where we get into MD5. Now, we're not going to be using keychains or anything fancy like that here. This is just going to be simply setting up basic MD5, which would be considered Type 2 authentication for OSPF. And again, this is a nice little section to read. And here is the OSPF. And you can see they're going to say that the header is going to be carrying this information. The OSPF packet header, when cryptographic authentication is employed, we've got the sequence number, and we are going to see this because we're going to set this up on real Cisco routers. I've already got Wireshark ready to go, and that's what we would see, right? You're going to see the key ID, you're going to see the authentication data length, and we're going to see the cryptographic sequence number, the hash that's generated so that we can see, okay, what's the hash that's being exchanged? So this is a good quick read and a little additional information to give you a better understanding of what you would want to do. So how do we do it? Well, first things first, we're on the interface, but I'm going to start here. We're going to go ahead and say router OSPF 1, and here's how you enable it for the area. So we're going to say area 0 authentication and message digest, right? So that MD5, and then that's it, right? It's area 0 authentication message digest. Now, this would be enabling OSPF authentication using MD5 for any interface that's in area 0, making it capable of authentication for any interface that's configured for area 0. Now, we have a single interface, so we're fine because that's the interface on which we are now going to jump into interface gigabit Ethernet 00. So again, we're going back into the interface, and this is where we say IP OSPF message digest key, and if I do a question mark, here's that key ID. Remember that from the header. There's the key ID. So we're going to say key 1, and we're going to use MD5, and here is where we put, you can think of it as the password or that this is the key. So the key number is 1, but then, oh, what's the password that key 1 is associated with? And here is where we're going to put in our capital A area 0 PA 55. I'm going to hit enter. You're going to notice we went up to 26%, and so we're good to go. Now, if the OSPF adjacency with router A was up, what we would have happening right now is our dead interval would be decreasing, right, 1 second at a time until it got to 0, where the adjacency would go down. Because in that OSPF packet header that we saw here as part of RFC 2328, this information needs to match, right? I mean, this is what we're doing. This is why we're doing it. And you can even see here, it says, you know, whenever the neighbor state transitions to down, well, it's going to be transitioning to down if this information doesn't match up. That is why we are enabling this authentication, right? Now, again, remember, you see the use of the word cryptographic. It doesn't mean that it is encrypting the OSPF traffic. It is not in this use case. What it's doing is it's going to put a hash in the header, and that is what is being used to authenticate the OSPF packets that are coming back and forth to make sure that router A knows it's router B and router B knows it's router A. So we've taken care of this here. Let's hit end and let's go ahead and say write mem. And now let's say show run and pipe it to section router OSPF. And that is the OSPF configuration section right now, leveraging type 2 cryptographic authentication. But again, it's not encrypting the traffic. And again, like I said, we're going to see that. So let's come over to router B and let's kind of walk through the same thing we just did on router A. We're going to get into global config. We're going to say router OSPF 1. I'm going to set the router ID here like I normally do to something conspicuous, where when I look at that, I'm not going to mistake it for an IP. I know that's going to be my OSPF router ID. We're going to say passive interface default no passive interface gig 00. Because that is the only interface on router B. We're going to throw a network statement in here for the 192.168.0 1.0.0.0.255, and it's going to be area 0. Now, if type 2 authentication was not configured between router A and router B, we would see the adjacency come up at this point because we have enough configuration here for that to happen. Again, if I go back over here to router A, we had the router ID, we had the passive interface, the network statement, the no passive interface, we would be good to go. But the problem is that we have authentication enabled. Now, let me take a look here and see, because we're going to have debug IP OSPF. Let's see what we've got. Let me try adjacency. That's as far out as it's going to go. And let's see what we see with events, if we can get any good information here, or if it's just simply, yeah. So actually, we do see something that's of interest to here, right? You can see OSPF every 5 seconds, and that is what I was looking for right there. Now, this is gold if you're troubleshooting, right? Because we're debugging the OSPF adjacency, trying to figure out why won't the adjacency come up? Well, take a look here. We can see router A sending youngest key, meaning it's the first key that was configured, because again, you could have multiple keys. It's the first key that was configured, but most importantly, what we're seeing, is this right here. In fact, let me go ahead at this point and say you all for undebug all, and let's take a look at what we've got here in this output. So I'm receiving an OSPF packet from 192.168.1.2. Well, that's router B, right? I was going to say router 2. It's router B. And why are we having an issue? Mismatch authentication type. Input packet specified type 0. In other words, the input, what I'm receiving is that router B is using type 0 authentication, null authentication, no authentication, right? And we, router A, we use type 2. So there it is right there, right? I mean, that's absolutely fantastic. I'm really glad that it supports this command and that I was able to demonstrate this. We would have shown you this anyway out on the regular Cisco routers, but it's great that you can see it here in Packet Tracer in the event you don't have real Cisco routers. So let's go ahead and take care of that here on router B. So now let me go ahead and say area 0, authentication, message digest, and that's it, right? So I'm just basically saying any interface I'm bringing up in area 0, I can now set it up to use MD5 authentication. So now let's come back over here. Let's kick the debug for the adjacency on here, and let's see what we see, if we see anything. And I may want to bring events back on. Yeah, we'll bring events back on because I think events is what is giving us that information. So we've got the debugging turned on, and again, you can see we, router A, are sending our key. And now take a look at the message, right? Let me go ahead and kick this off, you all. So undebug all, and I'm going to give us a little more room here so that we can see. Remember, before, it was mismatched authentication type, input packet specified type 0. We use type 2. Well, now what are we seeing? It's not mismatched authentication type. It's mismatched authentication key. No message digest key 0 on the interface. So in other words, there's two things going on here. This right here is saying mismatched authentication key. The key is this area 0 PA55, because remember, we issued the command area 0 authentication message digest on router B. So now router B is configured for type 2 authentication, which is why we no longer see that input packet specified type 0. That message is gone. What we see is no message digest key 0 on interface. That's router A saying that what I'm receiving from router B is this key 0. Like there's no key, right? There's no key configured, so I'm just getting key 0. And I don't have an MD5 key 0 configured on my interface, on router A's gig 00 interface. And what's happening here, it's key 1, right? Remember, on A, we've configured key 1 on the interface. So what do we need to do to fix this? Well, we need to go back And let's turn on the debugging of the events here. And here we go. So it's the events. I apologize. I think I'd said it was the adjacency that was giving us this output. It's the events. And what we should see here, and again, we haven't even set the hello and dead intervals yet, because that would kill the adjacency as well. But again, the problem is router A is receiving a key that is key 0, meaning we don't have a key configured on the interface on router B. So the mismatched authentication key is the problem now, right? Not the mismatched authentication type. And so questions that you should be prepared for, you see debug output like this, it might be asking you, what's the problem? And one of the answers could be, oh, one router's using type 0 authentication, the other's using type 2. And that would not be the problem. That would be mismatched authentication type. The answer would be that type 2 authentication is configured on both. However, the keys don't match, right? All right, whoops. So we'll leave that running here, and let's come up to router B and let's finish out the int gig 00 configuration here. So to prove to you that the hello and dead intervals need to match, let's do this. IP OSPF message digest key 1, MD5, and we're using capital A, REA 0, PA 55. So now this mismatched authentication key should go away. And so now what is the problem? Yes, and we've seen this in the previous video, 721, Packet Tracer Activity 721. The hello and dead intervals are broke. So there are myriad things that can be broken here in this configuration, preventing the adjacency from coming up. And again, I think I've hammered enough here on the MD5 authentication, right? The type 0 null, type 1 simple, which, and again, 0 and 1 you want to avoid at all costs. And this is what you want to use. And I don't know of any routers today, even going back to 12.x code, where you couldn't get simple MD5 authentication, just like this, configured to provide some sort of authentication between routers so that they know, excuse me, so that they know which router is which, right? Or that they know that the routers could be trusted, right? And so here we go. Hey, we've got bad hello intervals. Let's come back over here. IP OSPF hello interval 5. It's still not going to work because, again, we have to force the dead interval to 20. Now that we have that, and let's go ahead and say write mem. Now that that's been configured, we should see that the adjacency between these two routers is going to come up, and the OSPF finite state machine works itself from down, init, etc., loading to full, right? Two-way, all the way loading to full. So now when I say show IP OSPF neighbor, show IP OSPF neighbor, we can see that we have a neighbor. And router B sees router 1. It sees its interface priority. And actually, I forgot to set that as well. Let's get back into global config. IP OSPF priority gig 00. I got to get into gig 00. IP OSPF priority value of 100. And that gave us a few points. And let me save the config just to make sure. So what we're seeing when we say show IP OSPF neighbor is the information about the neighbor, router 1. The OSPF priority is 150. We are fully adjacent with that router, and the state that I see that router as is the designated router. There's our dead timer, and we'll probably never see 20. You typically will see like 19 for whatever reason. I never seem to be able to, yeah, there you go. I never get it right at 20. We see the interface address, and we see the interface out which we know about that neighbor, right? And so that is everything that we had to do for router A and router B. So something else that we could see on router B here, show IP OSPF interface. I think you can say gig 00. Yeah, there we go, to narrow it down. Even though it's the only interface, you can specify the interface and take a look. Who's the designated router? Well, there's the router ID for the DR. and that is router 1. If I was to say show IP OSPF database, we're going to see type 1 and type 2 LSAs in here. And those are the only LSA types we're going to see. And here is your type 1 LSA. We see the router LSA for router 2 and the router LSA for router 1. And those are exchanged between all of the routers that are OSPF speakers. And then here is your type 2 LSA. And the type 2 LSA is identified. The link ID is the interface IP of the designated router. The BDR is not going to show up in here, right? This is telling everyone who has this OSPF database that for this network, that is your designated router. In fact, we can stretch this out. We can look at the router LSA, right? Or LSAs, we have 2. So here's the router LSA for router 2. It gives us a little additional information. And this is how the graph and the shortest path first calculation all gets done, right? You can also see, you can also see the type 2 LSA. So here is the OSPF router with router ID 0002, right? And, here we go. Yep, so I'm looking for the advertising router, and this is the address of the DR, right? And so this is what I'm seeing is who is my designated router? It's router 1, 0001. Remember, that router ID is like a fingerprint that identifies an OSPF router and makes it unique and differentiates it from all other routers in that OSPF area. All right, so on to router C, where I'm hoping we're going to be looking at about 47% so that we don't have to go back and look at anything that may have been overlooked. All right, so on router C, we're going to go from user exec to privilege exec into global config, into router OSPF1. Now, the process ID does not have to match for OSPF, right? I could use router OSPF 99 if I wanted to. It doesn't have to match, not like EIGRP does. So we're going to go ahead and say passive interface default, no passive interface gigabit Ethernet 00. We're going to say router ID 0.0.0.3 to pull it together here. And so network address for the LAN interface. So we look up at the addressing chart. Hey, okay, it's in that same /24, so pretty simple, right? This is pretty straightforward, 192.168.1.0.0.0.255. Now, if it was me and this was the CCIE exam, I would be using the exact interface with quad zeros here, right? So get used to that, and that is considered a best practice, right? To not leave anything to doubt, because ultimately what would happen is this network statement is going to look at the interface to see what the mask is, the subnet mask is on the interface, right? So we'll go ahead and say area 0, and I'm just reading the instructions here. Oh, set all interfaces to passive by default. Okay, so I did that, but allow OSP updates on the LAN interface. Set the router to, okay, right. So we're going to distribute default routes. Well, the first thing we need to do, let's say do show IP route here. Okay, so no default route has been configured. We're going to be doing that, right? So, but here is where we would say default information originate, right? And that, once the default route has been configured, which we're going to do in a second, this would precipitate router C originating, i.e. advertising a default route to the other OSPF speakers in this OSPF domain. So for example, on router 1, let's get this off you all. So on router 1, router A, I'm sorry. On router A, if I was to say show IP route, we don't see a default route. You can see gateway of last resort is not set. So unless I'm receiving packets for these directly connected networks here, I don't know how to route anything, right? I'm not going to be able to route anything because my gateway of last resort is not set, but that will change and we will get an OE2, which is an external type 5 LSA for that default route that's going to be originated here off of router C. So let's see what we've got. Do show run pipe section router OSPF. And what do we have here? So everything looks pretty good here. and they've got to have us do the authentication. And so I'm going to go ahead and do that right now. So we're just going to say area 0 authentication, area 0 authentication message digest. And we'll get that taken care of. All right, so let's pop out of here real quick and let's configure that quad 0 default route. Now, it says configure a directly attached default route to the internet. And what does that mean? Well, that means I'm going to say that is the directly connected interface, and the points, we got a single percentage point for that. That's going to let us know that we've got that configured properly. So now do show IP route. So you can see here we've got this static route configured. We're originating that. We're advertising that into OSPF. If I come over here to router B, show IP route. Oh, OSPF adjacency is not up. I'm skipping steps here. Sorry about that. I forgot. We've got some things we still need to do. I did the authentication areas, the area 0 authentication, and we've got other stuff we've got to do here. All right, so we've already set it. We've did the default route, configure the directly attached. Okay, so the priority. So now let's get into interface, gigabit Ethernet 00, and let's bring this all together so that we can see the OSPF domain properly configured, fully configured, and we can see that default route and that we've received that default route. So IP OSPF priority is going to be 50, meaning that this would be the third choice to become the designated router. If an election were to be held, we're going to say IP OSPF hello interval is going to be 5. IP OSPF dead interval is going to be 20, and IP OSPF message digest key 1 MD5 and area AREA 0. I'm sorry about that. I had forgotten it temporarily there. All right, so area 0 PA55, and that is going to take us to 96%. So we missed something. We'll figure out what that is here in a second. Now it's saying, okay, so we don't have to issue that. Oh, wait, we have to wait and see. Maybe the default route doesn't get sent out. Router A should be the DR. So let's come over here to router A and let's take a look here now and say show IP route. And there it is. There is our OE2, right? That external type 2. If you look up here, you can see. And it comes in a type 5 LSA, but it's a type 2 external route. So external's type 5 in terms of OSPF LSAs, and this is a type 2, right? Which is the default for anything that is any route that is from outside of the OSPF routing domain. And so I'm sure that there's something silly that I overlooked here. Let me look at this really quickly before on the LAN interface, and that is correct. And that should have been it. All three routers should be able to ping the web server. So let's give it a go here. So ping 64.100.1.2, and we'll bring router B up. Yep, so we've got connectivity from router A, and ping 64.100.1.2, and it works. And then router C, which is pseudo directly connected here, we're going to say ping 64.100.1.2. And I'm sure while I was talking, I forgot to do something. Let's take a look at our results here real quick. And the authentication on the gigabit Ethernet interfaces. So it doesn't like the authentication. Well, that's interesting. Hold on one second here. Let me take a look at that, because that should be correct. Show run int gig 00. And we're just going to have to say show run here because it doesn't allow that. So under the interface, do I have something wrong in... And that should be correct. And again, I'm just looking at this to see... Message digest key 1, and it was key 1 that they wanted us to use. Maybe is the key number wrong? And that should be... So what they might have wanted here, and let's check, and this is one of the tricky things about OSPF authentication. So you'll notice that what I've done is working. right? We've got end-to-end connectivity. I've got show IP OSPF neighbors. I've got my neighbors. So what they must want here is they must be looking for us to do the following. So let's get into global config and let me see if this is going to work. Router OSPF1, we're going to say, no area 0 authentication message digest. And we're going to get into the interface, right? So you can drop it there, but you can also come into the interface, and now I am IP OSPF. Oops, sorry. Authentication. Yeah, so it's going to go down authentication message digest. Maybe they want it under the interface. So this is one of the things with OSPF that's always confusing. And I'll bet you this is what they want. I'll bet you they wanted it under the interface. And maybe I didn't read the instructions. You can see we're back, right? Excuse me. And, well, shoot, it dropped us down to 91. So this is the other way to do it, right? So you can do it under the area. And again, my impression of what they said here was that it would be done under for area 0 under the OSPF configuration section. And that might be why now we're down to 91. And that key is correct. So hold on one second here. Is that IP OSPF message digest key 1 MD5? And that's right. I'll just put something in here, and I just want to see. Yeah, so that is right. So it does not like the authentication configured. Because again, you can do it for area 0, which is what we initially did, and we got up to 96, and then we're here. But let's see if it doesn't like, let's see what it doesn't like now. It still doesn't like the authentication. And yeah, so it should be area 0. So we had it right. And now it says that it is correct for router A. Okay, so if I'm reading that properly, then, whoops, we didn't want to drag that over there. Okay, so then let's do this. So let me grab router A here, and let's go back into router OSPF1, and then let's drop this back in. Area 0, authentication, message digest. And that puts us at 97. All right, so that is very interesting. And this is, again, you can tell that I don't do these activities. You know, I don't pre-can what I'm going to do with these activities. We just dive right in. So this is interesting because keep in mind, you can, what I just showed you is you can do the area 0 authentication message digest under the OSPF config section and then drop the message digest key under the interface. Or you can put both the key and the authentication message digest under the interface if it's just for that interface and not the entire area. And what's interesting is it looks like this activity is not going to allow you to do it the two ways that you would do it. It's going to make you do what would be, and I'll call it an incorrect approach. I mean, it's going to work, but it doesn't make sense that we go back under the interface. So again, what they're looking for here is if I came in here and said interface gig 00, this will fix, this is going to give us the 100%. IP OSPF, authentication, message digest. So we're at 97%. We're at 98%, meaning when I come to router C, we're going to get into global config, interface gig 00, IP OSPF, authentication, message digest, 100%. But again, you don't have to do it like this. And so I guess I've got an issue with this activity, having you put it into the OSPF stanza, configuration stanza in global config, and then having to do it both, like you're basically doing it both ways, but you don't have to, right? You could do one way or the other way. And I guess you might make the argument, well, they said area 0. I get that. But if it's the interface is in area 0, then let's just do it under the interface instead of putting that statement there, all we would need, as you saw, and the adjacency came up, were the IP OSPF authentication message digest. And so finally, let's step out here to real routers and let's take a look at a packet capture. And so we're going to come on to router 8 here. We're going to get into global config. I'm going to get into int gig 00. I'm sorry, this is fast Ethernet 00.10. Interface fast Ethernet 00.10. We're going to say IP OSPF1 area 0. And so let's do what we just did. I'm going to say IP OSPF, IP OSPF, and IP OSPF. I'm sorry, I keep misspelling OSPF, and I should probably look at that first. So IP OSPF, message digest key 1 MD5, and I'll just say Cisco. Cisco. And then if I was to say IP OSPF authentication, right, here's where we would say message digest. And that's it. So, and that's all that's going to be required, because watch what happens. I'm going to come over here to router 9. And before we do that, we can kick off our packet capture here. And we should actually see right now on router 8, every 10 seconds, there it is. There's the hello packet. So let's stop the capture and let's look at this hello packet. Because what type, oops, sorry, wrong packet. Let's take a look at that hello packet. Let's look at the OSPF. Let's look at the header. Because where is it that we would see the authentication type? Cryptographic type 2. There it is. And here's the data. There's the sequence number. There's the key ID, because I used key 1 when I set it up. Here's the data length, right? So that's the information that we just saw. And this is the information that's being vetted between the two routers where authentication is configured to determine, hey, is this a trustworthy source? And so now watch this. So here's what I'm going to do over on router 9. So on router 9, I'm going to say router OSPF1, and let's do, so I'll mix and match, right? So on the left-hand side, on router 8, I should say, I've got it under the interface. Here, we're going to go ahead and say area 0, excuse me, authentication message digest. Then I'm going to jump into FA00.10, and let's go ahead and say IP OSPF1 area 0 first, and then IP OSPF authentication. Oops, sorry, we didn't want to do that. We did that under the area. Sorry about that. IP OSPF message digest key 1 MD5 Cisco. And let's see if this brings up the, and there it is. And there's your adjacency, right? So I can configure type 2 authentication 2 different ways. In fact, let me make sure over here. Let's go into router OSPF1, and I'm going to say no, no area 0 authentication, and I'm message digest. Yeah. So just to make sure that if it was in there, that it's not in there. So, and I probably should have said do show run section router OSPF. Is the area 0 authentication message digest configured? No. In fact, the only thing in there is the router ID. That's it, right? And do show IP OSPF neighbor, and we should probably see the serial interfaces as well. We do, and we can tell which is the serial interface over here on the far right-hand side. But take a look. We're at 33. Are we in the countdown to extinction? 32. The neighbor went from full to down because I pulled it out. So it was in there. And so the serial interface was using that. But you can see here, right? It works like a champ on fast Ethernet 00. So we've configured MD5 authentication. And let's go ahead and we'll wrap this up here. Let me drop to the slide. And this is important. So you saw in the packet tracer activity where they had you put both of the commands under the interface and under the OSPF configuration section. That is not required. It's not required. Now, in packet tracer, it worked great, right? And that's fine. And we actually saw on real Cisco routers it works as well, but it is not needed. You can do it only under the interface with the 2 commands that I showed you. the IP-OSPF message digest key command, and then the IP-OSPF authentication message digest command under the interfaces. So if you went interface by interface, you could do that. If you knew you were going to enable it for all interfaces in area 0, then you would do it under the OSPF configuration stanza with the area 0 authentication message digest. Then go under each of the individual interfaces and put the IP-OSPF message digest key. So there's 2 ways that you can configure it. And again, I did not set that up that we would run into the, hey, we're missing points, and Packet Tracer wanted us to do it like that. All right, well, that is going to do it for this Packet Tracer activity on implementing advanced OSPF v2 features. And we went deep dive into Type 2 cryptographic authentication, saw both ways that we could set it up, saw how we could debug it, saw what the packet capture looked like with Wireshark, and you are now at 100%. As always, thanks so much for watching, and I hope to see you in the next video.